All right. Anybody need a pencil? All right. Like I see dictionaries. Does anybody need another copy of a dictionary page? All right, cool. Let's go and get started here. Our first definition, ray. A ray is a line that extends indefinitely, meaning forever, in one direction. So a ray is a line that extends indefinitely in a single direction. We're gonna do a little diagram. And I'm going to tell you about how to name these things because naming these is a little bit more technical than naming a line or a segment. So go ahead and get that written down. A ray is a line that extends indefinitely in one direction. So what that means is it has an endpoint, and then it just goes in only one direction. So it's not a segment, it's not a line. So that's why it has a different name. It's a ray. So we got A, we'll call that B. And with line, the symbol that we use for line is the line that has an arrow at each end. With a segment, the segment was just a distance between 2 points, and so it was just a line above the 2 letters with no arrows at all. What do you think this one's going to be? Symbol-wise. Yeah, line with 1 arrow. However, this one matters which letter comes first and which letter comes second. With lines, it didn't matter because they go either way. With segments, same thing. It didn't matter because it was bound between 2 points, so it could be either way in terms of the letters. So like this segment here could be segment AB or it could be segment BA. It didn't matter because it goes back and forth. However, here, this one has a start point and it goes through another point. So it does matter how we write the symbol above the letter. So if you write AB, the part with the arrow has to go above the B because it starts at A and it goes through point B. So direction with these matters. Does that make sense, hopefully? So we start at A, that's where the non-arrow is, and then B is where the arrow is, so arrow goes above B. You could flip the letters around and say BA, but if you flip the letters around, what do you think you have to do with the symbol? Flip the symbol around, right? So if we start at A, it would still go through B. Those two things are saying the same thing. This is ray AB, this is still ray AB. When you name a ray, you always start with the end point, and it goes through the other point in terms of the arrow, directional. So that is an important part of naming rays. Direction matters. If you put an arrow above the wrong letter, like on a test or a quiz, I will mark you down ever so slightly. I'm not going to like say you're wrong on this entire problem, but it would be a little bit of a deduction. All right, so that's what a ray is. An angle, you've all seen angles before, I'm sure. Does anybody need more time with ray? Okay, angle. You all know what an angle looks like, but now we're going to learn how to actually visualize it and name it and all that kind of stuff. We'll spend a lot more time on this in our notes, so I'm going to be pretty quick with this. So an angle is the intersection of 2 rays at a single endpoint. The intersection of two rays at a single endpoint. That is the definition of an angle. So basically, two rays that meet at one endpoint create an angle. So I'll go ahead and use A and B again here. So A is our endpoint, and it goes through point B. So there's one ray. Definition-wise, it says two rays. So we need another ray on here. But they also intersect at a single endpoint. Well, if this endpoint is A, then the other ray also has to have that endpoint of A because they're intersecting at that endpoint. So the other ray could come off like that. And then we've got a third point down here. We can call that C. And hopefully you can see that there's an angle formed by those two rays. It's what? I think I heard you say it, right? It's acute, right? Yeah, it's an acute angle. Yeah, exactly. Because it's less than 90 degrees, right? Which is going to be one of our definitions on here. So naming an angle, we have a symbol for angle. Naming an angle is also a very specific thing. So there's two ways to name this angle as it is currently written. Anytime you name an angle, you have to name it based off of the point where they intersect, which is point A. And that it's called the vertex. You're going to use all three letters when you name the angle, but the vertex must be the point in the middle. So for example, we would call this, here's our symbol for angle. It kind of looks like the less than symbol, except it's like flat across the bottom. So that's angle. And then we could say, we start at B and then go to the middle and then go to C. So angle BAC. The point where the two rays meet, point A, is what's called the vertex. We'll talk about that with our next definition. There he is. So let me get some papers here. Trade you. There's that, and then this, and then this. So we're gonna spend 2 days on these. All right. All right. So that would be called angle BAC. So as long as where the hinge, basically the hinge is, right? Where that angle is hinging, if it were to open wider or smaller, it would still be hinging at point A. This one has to be in the middle over here no matter what. So this would be angle BAC. What's another way to write this with A in the middle? Yeah, CAB. So those are the two possibilities for writing that angle, BAC or CAB. Those are the only two possibilities. If you change the order of the letters after that, you're no longer talking about the angle that's right here. You're talking about a different angle. So that would be angle CAB. So two possibilities for naming that particular angle. Whenever you name an angle, use the symbol for angle. Kind of like we have the symbol for segment or line or ray. We also have a symbol for angle. All right, now vertex. I'll leave angle up there just in case you need to get that. All right, vertex is the common endpoint of an angle. It's where the sides intersect, or we could call this like I'll just say the hinge point. So let's just reference our vertex from our definition of angle. Which of those 3 points is the vertex? A, yeah. So A is the vertex of angle BAC. A is the vertex of angle BAC or angle CAB, however you want to write it. All right. And by the way, since we're filling out the rest of our dictionary, you can be sure that there's going to be a lot of terms that we're going to be talking about in this particular lesson. Basically, half of all the terms from this entire unit is in this lesson. Speaking of lessons, by the way, we only have one more lesson in this unit after this one, which means that your first unit test will be coming up probably around Thursday or Friday of next week. Because we've done 2 lessons so far, and we only have 2 more. This first unit is short; it's only 4 lessons. So, and by the way, in terms of what's actually on the test, it's actually only lessons 1, 2, and 3. There's like a bonus lesson that we're going to do on Monday, but that material will not show up on your test. It will be an assignment that you'll have to do because we'll do a bunch of stuff with that kind of stuff later on in the school year. It's based on like basic area and circumference stuff that you probably are familiar with already. But geometry has a lot to do with that. So we're just going to set up a little bit of that before we take our unit 1 test. But the unit 1 test will only consist of lessons 1, 2, and 3. So, all right, next one, a right angle. I think most of us know this. So who can tell me what a right angle is? Yeah, an angle that has 90 degrees, exactly. So angle with a degree measure of 90 degrees. So right angle is an angle with a degree measure of 90 degrees. And our diagram for that in terms of symbols, does anybody know the symbol that we put in this angle to indicate that it is a 90-degree angle? A little box. Yeah, it's like a little squared off. So I'm just going to do right here and then straight down there. That indicates a right angle. I'm sure that most of you, if not all of you, have seen that. And so what we would write here is angle X, Y, Z is a right angle. And I'm just going to abbreviate right to RT. You can do that. You'll see a lot of abbreviations in geometry as well. RT is an abbreviation of right. So we can say angle XYZ is a right angle. And I'm not even going to write the word angle. I'm just going to use the symbol for it since we've seen that symbol. What's that? Yes, is. Yeah, is. Yes, sorry. Sometimes my letters kind of blend into other letters. Yeah. Angle XYZ is a right angle. All right. The next one, again, I'm pretty sure most people know this one as well. In fact, it was already said earlier with the original angle. What is an acute angle? Yeah, it has less than 90 degrees. So an angle, so angle with a degree measure less than 90 degrees. So in terms of our 90-degree angle up there, if this top part were brought in a little bit or the bottom part were brought up a little bit, that would then turn it into an acute angle because it would end up making it less than 90. So we can just do, I don't know, anything here. Let's say this and that. That would be acute. We don't need to name this angle necessarily. And let's see, we can maybe say that is, I don't know. Let's put a number that's less than 90. Let's just say that's 50 degrees. I'm not sure if it's 50 degrees or not, but that's what I'm going to write in there because it looks like maybe it's about 50 degrees. All right. Next one, obtuse. What is obtuse? Big. I mean, yeah, big, meaning what specifically for angles? More than 90 degrees, yeah. Acute would be less than 90. If you got 90 and you open it up more, that would be more than 90 degrees. So angle with a degree measure more than 90 degrees. All right. So I think we're all familiar with this one as well. And so let's see, if we go with an angle that looks about like that, this one would be obtuse. That's more than 90. So let's put a number in here more than 90. Let's call that 120. Now, there is actually a limit to how big an obtuse angle can be. So yes, it's more than 90, but it's also, and we're not going to write this down, but it is also less than 180 degrees. So an obtuse angle can't end up being more than 180, or it can't end up being more than, I guess, 179.99, whatever. It's got to be less than 180. Okay, let's go to the next one, congruent angles. Now, we have a definition of congruent segments already. So based on our definition of congruent segments, what do you think congruent angles will mean? Same angle, yeah. So angles that have the same measure. Angles that have the same measure. I'm going to be more specific in degrees. So for example, it's going to have to squeeze some stuff in here. Let's say we've got this angle here. And we'll call this one angle ABC. And then this angle over here, we can say, well, let's go with RST. So the degrees of angle ABC, 30. I didn't have room to write 30, so I drew an arrow to it. Yes. That's RST. Yeah. So we got angle ABC, 30 degrees. We have angle RST, 30 degrees. Now, the length of the rays, you'll notice that the length of the rays here that are actually drawn, the rays look shorter on ABC than RST. That has nothing to do with the measure or the degrees. The degrees is how big the opening is in between the two of them. And so if the opening is the same size in between the two, it doesn't matter how long we draw those rays, as long as the degrees are the same, the angles are congruent. So we would say this, we would say that angle ABC is congruent to angle RST. That would be the symbolic way of writing congruence. So instead of writing out a whole bunch of words, angle ABC is congruent to angle RST, we have a much shorter symbolic way of writing that, which is, I think, pretty convenient. Yeah, you got to learn some symbols, but it makes it a lot shorter to actually write these sentences. All right, that's it for that page. Get your last page of your dictionary out because we got some more things to talk about. And then we'll get started with the notes after that, and we'll work on them, as much as we need to today, and then finish them up tomorrow. All right. Anybody need more time with this page of your dictionary? All right. Okay. Cool, let's keep going. So the next one is the word adjacent. Adjacent is just a single word way of saying next to. So it's a little more detailed than that in terms of what we're going to write for our definition. But that's how you can think of it practically. It's the angles that are right next to each other. But specifically what it means is angles that share a common side. By the way, a side of an angle is one of the rays. So they share a common side, they share a common ray. And a common vertex. So underneath that, you can just do kind of like the plain English way of saying angles that are next to each other. So the math definition is up top, and then like the, conversational way of saying it would be the second sentence there. So they're angles that share a common side, a common ray. They also share a common vertex. And basically what that means is they're right next to each other. So for example, you're going to see another way of naming angles here in just a second as well. So what we're going to do is draw a large angle that looks like that. And then we're just going to draw a ray in between the two, about like that. They don't have to be the same size angles. They just need to be next to each other. So another way of saying this, or another way of naming angles outside of using points, is sometimes you'll just see numbers in between the rays. That's a 2 down below, by the way. We got angle 1 up top and then angle 2 there. These two angles share a common side. The ray that's in the middle is the side that's shared between the two because it's part of angle 1 and it's part of angle 2. And they have the same vertex right down here. So we could say that angle 1 and angle 2 are adjacent. Angle 1 and angle 2 are adjacent. They're right next to each other. That's what that means. So if you've ever heard somebody give directions before and they're like, yeah, you're going to head down to the Safeway that's adjacent to the Staples, right? Adjacent just means next to. They share a wall basically, right? They're right next to each other. All right, next one we're talking about vertical angles. Now, vertical angles, it's a little bit of a weird term because when you think of vertical, I'm guessing you think of like straight up and down. But vertical angles could be that, or it could be something else. So let's go ahead and get this written down. Vertical angles, here we go. 2 angles directly across from each other on intersecting lines. That's an important part of this as well. So there are 2 angles directly across from each other on intersecting lines. We'll get a diagram of that going in just a second. But we're going to write one more thing with vertical angles. And this next thing is super important. This is something that you will use all year long, I promise. There is a specific relationship between vertical angles. And that relationship is they are congruent to one another. So I'm going to do a red star here and say vertical angles are congruent. So that is something that you will use over and over and over and over again. So now we get to see what they look like. So it says that they are angles that are directly across from each other and they're on intersecting lines. So we're going to draw two lines. There's one line, and here's another line intersecting with that. And I'm just going to name 4 angles here. 1, 2, 3, and 4. We got angle 1 on the left, 2 on the top, 3 on the right, 4 on the bottom. And vertical angles are the ones that are directly across from each other. For example, angle 1 and angle 3 would be vertical to one another. Even though they're not vertical in terms of their orientation, they're not up and down, they are directly across from each other. That's where vertical doesn't really always work exactly. But I mean, if we turn the paper this way, then they're vertical. So like vertically vertical. So vertical angles does not mean straight up and down. It can mean that because angle 2 and 4 are also vertical angles because they're directly across from each other. So we would say angle 1 and angle 3 are vertical. So are angles 2 and 4. We're not going to write that, but they are. We also wrote this thing right down here that vertical angles are congruent. So in terms of showing congruence within angles, I'm going to show you how to do that real quick. So angle 1 and 3 would have the same angle measurement. Angle 2 and 4 would also have the same angle measurement as each other. And the way that we show that, with segments, we did like the little tick marks through the segments. With angles, we're going to do a little arc right in the angle. So this little blue arc here and this one over here with angle 1 and 3 mean that angle 1 is congruent to angle 3. Now, there's a way that we can show angle 2 and 4 congruent as well on the same diagram. And so if you have more than one set of congruent parts, you would end up doing more than one line. So the 2 lines there and the 2 lines there mean that angle 2 and angle 4 are also congruent, but they're not congruent to angles 1 and 3 because they have 2 lines, whereas angle 1 and 3 only have 1 line. So these are congruent to each other, and these are congruent to each other. We're going to be doing a lot with marking angles and talking about vertical and congruence and all that kind of stuff as we go through a lot of what we're dealing with. In fact, I think we have, we're going to have an entire unit where we're going to be dealing a lot with like angles specifically. All right, next, complementary angles. Some of you might know this definition. Does anybody know it? Complementary angles? If not, that's fine. All right, so complementary angles are 2 angles that add up to 90 degrees. So any 2 angles that add up to equal 90 degrees would be considered complementary angles. I'm going to show you 2 ways that angles could be complementary. Sometimes they're adjacent, sometimes they're not adjacent. So sometimes they look like this up here, and sometimes they don't. So, for example, if you have an angle that looks like this, and then you have a separate angle down here that looks like that, I think we can agree that these angles are not attached, so they're not adjacent. Let's say that this one up top is 40 degrees and this one down here is 50 degrees. What does 40 plus 50 equal? 90, exactly. So those 2 angles would be considered to be complementary because they add up to 90. Now, if the angles happen to be adjacent, it's usually easier to see that they are actually complementary. So the other way that this happens is sometimes you'll have a diagram like this. And sometimes you won't have any numbers at all to work with, but you will have this symbol right here. That symbol means that the large angle there is 90 degrees. So no matter what, if you have something, if you have a ray going through it, creating adjacent angles here and here, those two angles have to add up to 90 no matter what. We don't know what the angles are individually, but we know that they're complementary because those two end up making this 90-degree angle. So either way, they have to be complementary. All right, let's keep going. Supplementary angles. Anybody know what that one means? All right, here we go then. This would be two angles. We're getting close. Two angles that add up to, here we go, 180 degrees. So basically just double complementary. Supplementary angles double the amount of angles or the number of degrees that complementary angles add up to. Once again, these don't necessarily have to be adjacent. So a lot of times they are, but they're not always. So let's see, if we have an angle that is, let's call this one 120 degrees. What would another angle have to be equal to in order to be supplementary with this one? 60, yeah. Because 120 plus 60 is 180. So the two angles have to add up to 180. So we'll just call that one 60 degrees. There we go. So 120 plus 60 is 180. So those two angles would be supplementary. Now, the next one I'm going to show you is what happens if you end up with supplementary angles that are also adjacent, that are next to each other. And that is what's known as a linear pair. So these are adjacent angles, so angles that are right next to each other, that are supplementary. That's our first sentence. And we're going to just add a little bit to this because we'll go ahead and write that down first. And let's talk about pair means two, right? So we're talking about a linear pair. Pair means two. So we're talking about two angles that are adjacent, that are supplementary. So adjacent angles, the two angles, that's our pair. What does the word linear remind you of? What does that sound like? Or if I cover up the A and the R, what word is that? Oh, there you go. You can actually see it now. Line. Yeah, linear means a line. So basically, it's two angles that are right next to each other that make a straight line. So combined, comma, they form a straight line. So anytime you see a straight line, lines have 180 degrees. So from like this part of the line, if you draw an arc all the way across like that, that would be 180 degrees. All right, so we're going to draw a line here. We'll do that. And then you can draw from any point on that line, just do another ray extending from that. And on the left, this obtuse angle, we could call that 120 degrees. This acute angle here, we can just call that 60 again, just like we did with our first example. But this time, those two angles, they still add up to 180, but now they're all part of the same diagram. They share a ray, they share a side, so they're adjacent. And when they form, they create a straight line when you put them together. All right, two more definitions. We're getting close here. And then we can actually get started on the notes, and we won't get far in them today. But I'll get you your assignment anyway if you want to get a head start. Anybody need more time on linear pair? All right, let's keep going then. Perpendicular, I think we know this one, right? What does perpendicular mean? sure people have heard this term before. So that would be the opposite. That's parallel. So which one would perpendicular be then? The parallel runs next to each other. Perpendicular would be like T, right? So it would be two lines that intersect at a right angle. So perpendicular, just two lines that intersect at a right angle. So for example, over here, there's a line, there's another line. We can call this one line L. We'll call that one line M. And those two lines have intersected to form a right angle. We also have a symbol for perpendicular that you probably learned last year in Algebra 1 because you talked about parallel and perpendicular lines in Algebra 1. So you don't actually have to write out the word perpendicular. You could say, here's line L. Make sure you get the symbol. There's line L. And then the perpendicular symbol is an upside down capital T, basically. So there's line L. This means is perpendicular to. And then you'd say line M. So line L is perpendicular to line M. And if they're perpendicular, that means they form a right angle, which means they intersect at a 90-degree angle. So there's a lot that we can actually kind of take out of that. All right, last thing here, angle bisector. We talked about a segment bisector already. And a segment bisector did what? Based on our definition, what did a segment bisector do? And then we'll use that to define an angle bisector. Segment bisector, what did it do? Yeah, it intersects a segment at a midpoint, meaning it cuts a segment in half, right? So technically speaking, a segment bisector cuts a segment in half. So what do you think an angle bisector is going to do? It's going to cut an angle in half, yeah. So a segment bisector cuts a segment in half. An angle bisector cuts an angle in half. So we're going to write a line segment or ray that divides an angle into two equal angles. That's just a long way of saying something that cuts an angle in half. So it's a line, it's a segment, it's a ray, one of those three things that divides an angle into two equal angles. So what that would look like is, let's say we've got ourselves an angle that looks like this. So here's our big angle. And so our angle bisector is basically going to go halfway through those. So that would be something right around like that. So this ray in the middle here would be the angle bisector. However, the thing that we need to take from this is the fact that the large angle ends up getting cut into two equal angles because of that angle bisector. So this angle here is congruent to that angle there. So those two angles have the same measure. So basically, if the entire thing was 60, this ray splits it in half to create 30 and 30. That's what we're talking about. All right. We still have about close to 20 minutes, so this is good. We got some time to get started on the notes. All right, I know that was a lot. That's a lot of stuff to go into one lesson, but this one lesson will take us 2 days. I would recommend keeping those out in front of you. Don't quite put those away yet because we are going to be using those definitions a lot as we go through these notes. So leave those accessible. And we're going to go ahead and start in with our notes now. So the topic today, we are calling this angle relationships. It'll be a 2-day deal. What is today? The 7th. All right. Now, based on our definitions, we're going to be able to fly through a lot of these notes, at least the first page or so. So we got our little diagram over here. And then based on our definition of angle, an angle is formed by two what? Based on our definition of angle. Go back to it. Somebody let me know. Rays. All right. So the word is rays. There you go. Angle formed by two rays with a common endpoint. Cool. The common endpoint is called what? That hinge, that point at the end of an angle. It's called what? It was the next definition. The endpoint, yes, which is called the vertex. There it is, vertex. All right. The rays are called, we didn't really write specifically this down. I did mention it, but we didn't really spend much time on it. The rays are called the sides. So if you hear sides of an angle, it's just talking about the rays. How many letters do you need to name an angle? 3. 3 letters to name an angle. Good. And then, like I said before, the middle letter must always represent the vertex. However, because there's always exceptions, right? Math always full of exceptions. However, you can use a single letter, but only if there's only one angle located at the vertex. I generally will not do this. I will pretty much always use 3 letters. I would encourage you to do the same. But basically, we could call this angle B if we wanted to, because there's only one angle here. So there's no confusing what it might be other than angle B. Where it could get confusing is if you go all the way to the bottom to example 2, every single angle here, angle 1, angle 2, angle 3, angle 4, and angle 5, all share the same vertex here at point T. Can everybody see that? Point T is the vertex for every single one of those angles. So there's no way we could say angle T. That doesn't make sense because we have 5 options coming up with angle T, or coming up with point T in terms of what the angle could be. So we would have to use letters or numbers to describe the angles down here. We can't just use one letter. So most of the time, you will not see me use one letter to name an angle. I would advise against it. It can be done. You might see it written on a paper here or there, but it's not something I'm going to do very often. All right. So when you're referring to the measure of an angle, here you go. This is something new. When you're referring to the measure of an angle, in terms of the degrees, you're going to write this. A lowercase m. What do you think m stands for? Measure, yeah. Lowercase m, in this context, lowercase m stands for measure. In other context, m, last year anyway, lowercase m meant slope, right? Y equals mx plus b. So lowercase m can mean different things in different types of problems. However, here, lowercase m next to the angle symbol means measure of angle. So the degrees in angle ABC would be 60 degrees. So the measure of angle ABC is 60 degrees. Anytime you are saying the angle degrees of an angle, use the lowercase m, use the angle symbol, and then you don't have to say 3 letters. Sometimes it'll just be a number. Sometimes it'll be like the measure of angle 1. Or for example, down here, you could say lowercase m, angle symbol 5, the measure of angle 5 would equal 90 because it's a right angle. So different ways of writing that. All right, let's keep going here. The types of angles here. What type of angle is this first one? Acute. What about the second one? Obtuse. And then the third one? right. All right. Let's keep going. So we got acute, obtuse, right. We've gone over pretty much all this stuff already with the dictionary, so let's move quickly. Name the vertex of the angle in example 1. What point is the vertex on angle 1? Over here, of example 1, I mean. K, yeah. K is the vertex. It's the hinge point of the angle. The sides of the angle would be both rays. So remember, with a ray, you have to have an endpoint going through another point. So like KJ. And then remember, symbolically above it, the arrow goes over the letter that the arrow goes through on the diagram. So you're going to have K through J, like that, with the arrow above it. The other side would be KL, with the arrow going above the L, because they have the same endpoint of K. So the sides here would be ray KJ and ray KL. All right, now there are 3 ways to name this particular angle. What would one of them be? We're using 3 letters. So what's one way to name it using 3 letters? JKL, all right, so angle JKL. Make sure the vertex is in the middle, so angle JKL. What's another one? K needs to be in the middle. LKJ, yep. So angle LKJ. And then the third one is the one that I'm not a huge fan of that we just saw above here. You can use a single letter if there's only one angle. So we could also call this angle K. You can name it based on the vertex alone if it's the only angle present. Which, again, I'm not really going to be using this. All right, classify this as one of these 3. Obtuse, yeah, that's more than 90 degrees. So obtuse. All right, so far so good? Not too bad yet, is it? By the way, this lesson should seem really similar to the very first lesson we did, but instead of like lines and points and planes, we're dealing with angles. All right, we got a lot of things to answer here. Name the vertex of angle 2. And I just mentioned a moment ago that every angle here has the same vertex. T, yeah. Angle 2 has a vertex of T because every angle here has a vertex of T. Name the sides of angle 4. So give me the rays that make up angle 4. So here's angle 4. So TW and TZ, good. So you got TW with the arrow above the W, and then TZ with the arrow above the Z, because the endpoint for both of those is T, and it goes through W on one side and through Z on the other, so those ones have to have the arrows above it. So ray TW, ray TZ. All right, how about C? Write another name for angle 3. So use 3 letters for angle 3. ZTU, great. So angle ZTU. The other option would have been UTZ, angle UTZ. You cannot call that one angle T because we don't know which one we're talking about if we say angle T. So it's either angle TZU or ZTU, sorry, ZTU or UTZ. How about another name for angle 1? YTX, great. Or XTY, either way. As long as T is in the middle. So angle YTX or angle XTY, keeping T in the middle. Name the sides of angle 5. TY. TW, good. So TY, so ray TY, arrow above the Y, ray TW, arrow above the W. All right, here we go. F, classify, acute, obtuse, or right. That's what it means by classify. Angle YTW. What's that? It's a right angle, yeah. Angle YTW is a right angle because of the symbol right here. It's angle 5, by the way. YTW and 5 are the same, so this would be a right angle. Classify angle YTU. Oh, that's interesting. YTU. Obtuse. Yeah, everybody see angle YTU? Take a look. So YTU actually is made up of both angle 1 and angle 2. It's this one here. And it's obtuse because if it was 90, it would be here. And it's more than 90, it's right there. So we got angle YTU. So that would be obtuse. Nice. How about angle XTU? Acute, for sure. That's the same as angle 2. And then the last one here, angle WTU. Obtuse, for sure. What two angles is angle WTU made up of? Use the numbers. 4 and 3. Yeah, so 3 and 4, angle 3 and 4, angle 4 and 3 make up angle WTU. That's a large angle going across right here. Okay. Any questions so far? Sometimes recognizing angles can be a bit of a challenge for folks. So if you're feeling pretty good about this, that's really encouraging. Visually and naming these things can be a struggle for folks at the beginning. So if you're feeling good about it, that's awesome. Go ahead and turn the page over. Let's keep going. No, not yet. Okay. Anybody need more? Okay. Other people need more time? I'll slow down for a second. Sorry. I just like angles. I'm getting excited about it. It's been years since I've taught geometry as well, so I'm happy to teach something different this year. It's good. Not that I don't like teaching algebra, but like when you do the same thing over and over again, sometimes it's exciting to do something different. So. All right, good. Okay, flip it over. Here we go. Let's get some diagrams out of the way here. So we have diagrams of all these things already, which is great. So go back to your page of definitions. And if we look at vertical angles, you can just copy down that diagram where it says example. So these are how angles can relate to each other. We got vertical angles. And there's more space here to do diagrams than we had on the dictionary as well. And I'm just going to draw the exact same one. So let's say we got angle 1, 2, 3, and 4. The only difference I'm going to do is I'm going to put the single arc with the 2 and 4 and the double arc with the 1 and the 3. Because it doesn't actually matter how you do those as long as you identify them in some way. So angles 2 and 4 would be vertical to each other, and angles 1 and 3 would also be vertical to one another. All right, let's try to get this wrapped up and then we'll be done for the day. So linear pair, let's move on to linear pair. We'll go clockwise here. So next one, two angles that are adjacent and supplementary and they form a straight line. So here we go. Here's our line. There's a line through our line or a ray extending from our line. And I think the example we said was, we said 120 here and then 60 over here. So linear pairs, if something is a linear pair, they must form a straight line and they have to be next to each other and they have to add up to 180. So there's a lot of different little things that have to happen to be a linear pair. A little bit less has to happen in order to be supplementary. These are supplementary, but there's other ways for things to be supplementary because supplementary angles do not have to be adjacent to one another. They can be, but they don't have to be. In fact, for this example, I usually draw two different examples here because we actually have room for it. So I'm going to do the same example I did for linear pair. We got 120 here and 60 here. But then I also do a couple over this way, and let's say I'll do a much smaller angle here. Let's call that one 30. Let's say 30 degrees there. How many degrees would the other angle have to be if one of them is 30? What's that? So if one of the two angles that adds up to 180 is 30 degrees, how many degrees is the other one? That'd be 120, wouldn't it? 30 and 90 would be 120. 150, yeah. So the other one, let's say 150. Again, I don't actually know if those are the exact measures of those angles. I'm just estimating based on what I can remember what those angles might look like, but 30 and 150 would add up to 180. So those would be supplementary angles. Two examples, adjacent and non-adjacent. Either way. Same thing with complementary angles. We had a couple of diagrams with complementary. You can just copy those from your dictionary, which is exactly what I'm going to do here. So let's see, we had one example where we had like a 40-degree angle-ish. And then the other one was around 50 degrees, about like that. So let's call that 40 degrees there and 50 degrees there. And then we also had one that was just a straight up right angle. And we didn't actually have any measures for those because we don't actually need them. What's that? This one's complementary. And you can just copy the notes that you had in your diagram from the dictionary. The complementary angles, they add up to 90. If they're both part of a right angle, you don't need to know the individual measures of them. You know they are complementary because they form a right angle. And then the last one we're going to do today, adjacent angles are angles that are next to each other. They share a common side. So any two angles we just call that angle 1 and angle 2. It doesn't really matter. Those would be adjacent. All right. Let's see. Who would be interested in getting a head start on the assignment, or would you rather just work on it? Okay, I see some hands. I'll hand it out. All right. So I'm just going to hand it out to everybody. We've got about 1 minute left, so just go and put these right away. 6. Feel free to get started on this. There's only a few of them on here that we've really think that we were actually being related because most of this lesson, or at least most of the assignment, uses the idea and blends it with some algebra as well, which we will look at tomorrow. So go ahead and pack your stuff up. The bell is going to ring in about 15 seconds.